Thanks for sticking around, iOS guys. Hopefully what I've tried to do is I'm going to do like a bit of an overview of Android security, so hopefully it'll be accessible for everyone, and then towards the end we'll get into more kind of more technical, more Android-y focused stuff. Just before I start, to give you a bit of context of who this guy is at the front, I'm from Bristol in the UK, which if you haven't heard of that, it's like about 120 miles west of London. I'm a freelance Android developer. I don't do speaking and stuff as my day job. This is for fun. So by day I'm a sort of Android developer, but I'm kind of quite keen on the mobile security side of things, and that kind of keenness led me to co-author the Android Security Cookbook a couple of years ago. And I also I work remote, but I kind of enjoy meetup groups like this, and actually run a very similar group. Wow, I did it on its own. I run a similar group called SW Mobile, which is kind of everything mobile, kind of based in the southwest of the UK. And yeah, so very kind of similar vibe, which is why I was keen to talk tonight at a sort of similar kind of group. And so I'm here in Poland because of MCE. I'm talking about security, that's all I talk about. But partly, what I'm trying to do is not cover anything that I'm doing tomorrow in case there's anyone coming along who wants to get like a proper double dose of security. So I will see you tomorrow, so I'm trying not to repeat anything. So like today, I just wanted to give like a brief kind of overview of Android security, a quick, like really quick scratch of the surface of reverse engineering, because if you haven't done that, it's quite fun and quite easy to do, so I'm going to give you some pointers of that. Then go through a couple of protection sort of tips, a little bit about encryption, and then just finish off by pointing to a couple of security testing tools that you might want to use to sort of verify your current apps, and those tools you can use on. They're mainly for Android, but they're similar tools that exist for iOS apps as well. So that's kind of the idea. So I don't know if anyone's familiar with this amazing graphic that looks crap on the screen, but Open Signals is an app, and every year they release a fragmentation report, and this is all the kind of devices, and the different square sizes are based on how large a percentage they are. This is all the sort of devices they get using their app. So I guess what I'm trying to say is probably something you already know. Android is diverse, together and not the same. That's the whole idea. So there's no like single point of failure. There's absolutely no the way it is. And if you ever hear anyone say, talking about this is the way it is on Android, this is the way security is, this is the way anything is, you know that it's BS really, because there's so much differentiation, so much diversity. And unlike iOS, where we have one manufacturer can push out updates and get like a really good uptake on those very quickly. That's not the same on Android. We have patches go into the open source project that has to be then picked up by the OEMs, which then have to do their testing on it. Carriers get involved. So even the simplest one-line security fix can take weeks and months to get to devices, and they might not even be supported anymore. So how does Google kind of handle this whole kind of problem? Well, what they do is they use a variety of security or a variety of services that they can sort of enhance the security of each kind of device. You're kind of probably familiar with Google Play. There's been a human involved in the app approval process since last year. They also last year started doing developer security notifications. So that was kind of like if you bundled, say, a vulnerable version of OpenSSL, there was also quite a significant vulnerability found in the Cordova platform. You'd get like an email notification, and in some cases they would pull apps that didn't sort of respond to that. So that's been a good way of sort of them scanning your app and notifying you of potential issues. And then also kind of in the background there's something called the Android Bouncer, which is a kind of process that goes and downloads all the APKs and stuff that are in the store, runs them in an emulated environment, and then tests them, for them potentially being sort of malware, and various other things. So that's the kind of Play Store. For more from a user perspective, you've got something called the Android Device Manager, which is very similar to Find My iPhone. You can find, lock, and even wipe devices remotely. Safety Net is something that is also relatively new, and it's a sort of an intrusion detection system. And this kind of like runs any device that's running the Google Play services. This will kind of run in the background, and they reckon they've got like over 1 billion devices that sort of builds up this picture that gives them, that sort of tells Google for potentially harmful apps, and they get like, they reckon about 150 million daily kind of devices kind of reporting in. It's all kind of anonymized, but it's a way of them detecting particular apps being, they call them potentially harmful apps. So it's not necessarily specific malware, but it could be something that's leaking data or stealing information. And then just lastly, there's Android at Work, which is a way of kind of segregating your business and personal apps, on the same device, but they're kind of like on separate kind of encrypted partitions, and you can keep that data completely separate. I sort of cribbed this slide from Adrian Ludwig's Android security State of the Union from Black Hat last year, because I thought it was kind of a good way of kind of like an onion effect of showing the different sort of layers. We've already kind of mentioned the Google Play Store, but I wanted to draw attention to this verified apps sort of segment, the yellow section in the middle, and that's Google kind of trying to identify potentially dangerous apps on non-Google devices. So that's, if I install an app, an APK file from the internet, from just from ADB from my computer, it offers you the option to go and do a signature analysis on that to see if it matches any known sort of malware. It's pretty rudimentary. I say rudimentary. It's pretty complex. We couldn't just create it just out of the script, like here tonight. But it's a good way. I think it's a good indication of Google trying to sort of, okay, we've targeted apps that are uploaded to the Play Store. How do we target apps that aren't uploaded to the Play Store? It keeps doing that on, I'm not doing that. It's automatically advancing the slides. Who knows why? Maybe it's someone trying to tell me to speed up. I don't know. So just a little bit on the clickbait headlines that you kind of all probably see. Certainly, it's definitely something the tech media love to go on about. The equivalent on Apple, I guess, is the App Store approval process. We all know that it's not as a big a deal as people make out. But yeah, there have been issues from a security point of view. Certainly, there's much more publicly disclosed malware on Android than iOS. But the one I sort of wanted to draw your attention to specifically tonight is app hijacking. Oh my God, that looks horrible. Sorry about that. Just because it's an issue you don't really get on iOS, because sideloading apps is a lot more difficult. You have to have a jailbroken iPhone. Whereas on Android, you just untick an option in the settings. Anyone can do it. And then if you want to use an alternate app store like Amazon, like Samsung, they're probably the biggest. Certainly in the UK and in America, you have to have that sort of option disabled. So the idea about app hijacking, it's also called Trojanizing of apps, is that you take a legitimate app, you reverse engineer it, and you put in some malicious code, repackage it up, re-sign it, and then distribute that however you want, whether you use an alternate app store that doesn't do any kind of approval checks. Maybe you just email it to known potential victims. So this is an issue because it's very easy to do that. There's no central certificate authority for signing apps, unlike with Apple. And of course, what I'll show you in a couple of slides' time, reversing Android apps is pretty easy. So this is certainly a cause for concern. No presentation is complete without a top 10. So I thought I'd show you a top 10. This is mobile security risks. So if you're familiar with OWASP, they're a kind of an organisation based on improving software security. You probably heard of them in the web context. There's also a mobile security project, and they have got like 10 areas of where the highest kind of risks are. This is the most up-to-date risk list. We're going to cover a couple of these tonight, but just more for your reference for you to look back on. This totally includes iOS as well, and there's some great information on the OWASP site that covers these, each section, the attack vectors for these, and also how you can sort of guard against it, and how you can sort of create better apps to sort of thwart these kind of risks. So yeah, this is like it's in draft. It's like release candidate at the moment. So they're encouraging feedback and stuff on those. But there's plenty of information. Let's go to reverse engineering. We have to have a Star Trek graphic, just because. So I thought we'd sort of cover reverse engineering because it's easy, it's fun. There's tons of tools that we can use for this, and there's also the kind of reasons that people would do this. I guess you could easily take someone's app that is ad supported, reverse engineer it, sort of decompile it, change the ad network ID, recompile it, upload it. Then any ad revenue generated by the app would go to you. If you could distribute it to the right people. Actual users, put it on a torrent site, for example. Good old software piracy. Remove the licensing checks. It's all kind of legitimate things you could do if things like tamper protection things aren't put into place. Of course, profit, which was the whole point of putting that silly graphic up. So just to sort of the tools. Again, this is more for if you want to come back to the slides and have a look. We're going to use APK tool in a second. I'm not brave enough to do a live demo, so it's just some slides. But these are some of the tools that you can use. There's tons more stuff. If you go to droidsec.org, on the wiki there's tons of tools. And there's tons of links to Android-specific white papers about security, which I'd highly recommend. Notable ones here like Jeb, if you're a security professional, you'll have heard of that, and that's probably one of the best tools you can use for Android-specific reverse engineering. It's expensive, but it's commercial. So let's hack an app, but not one of your apps. Let's hack one of my apps. This is an app that I wrote a couple of years ago. It's a really simple, noddy app. It was a couple of lunchtimes work, and it basically just does this. It's an extension for an existing app, but it's its own self-contained APK, and it basically gets your clout score. Has anyone heard of clout? Oh wow, that's more than ever. Like no one ever heard it. No one. So clout is just something that kind of aggregates all your plus ones, your retweets, your recommendations on LinkedIn, adds some magic, and then comes up with a score between like 1 and 100. And I thought, oh hey, this is a new service. I'll just write a quick extension, and maybe I'll hack it later on and use it in a presentation. And that's what happened. So it's a very simple app, and all we do, we just get the APK file from our Android device, and we don't even need to have it rooted. We don't need to have any specialist software. We can use ADB. There's a couple of commands to go and get that, to find the location of the APK file and get that. Or there's plenty of apps on the App Store that you can freely download that will just send it to you in an email. That couldn't be simpler. And they're legitimate, legitimate apps for backing up your apps. Yeah. Go.
Isn't there a sandbox that will prevent apps from just getting an APK and mailing it to you? Or?
No. Well, it's just an APK file. It's just a zip file with your stuff in it. I mean, yeah.
Okay.
Yeah, it's no. Yeah. It's fun times. Yeah. So all I did was I cut out that slide, and what I'm doing, I've installed APK tool. And I'm just running this simple command, and what I get out of that is all my app decomiled, my nicely named classes. What they do is they're converted into Smiley code, which is kind of like an assembly sort of representational language. It's actually not that hard to read, and you can quite easily get the makeup of an application quite easily. You can see this was ages ago. It uses things like Android Query, which has been, dead for ages. I hope the author isn't in here tonight. That would be well embarrassing. So this is just an example. I wrote the app, so I knew where to look for the scary secret stuff. And you can see, if you're familiar with programming at all, that you could read this. You could, and obviously you could automate this kind of attack very easily. And so this is just the API key. It's not particularly that scary and something you want to cry about. But saying that, if you wanted to denial of service attack my app and sort of use up the free limit for the API calls, you could take that key and do that. I suggest go for it. No one uses the app, so go for it. But obviously doesn't make any difference to this sample app. But if this was you were using a paid API where you were paying per hit or per 100 hits or whatever. Also think about what if that was an encryption key that we're using to encrypt your data. You thought you were safe. Oh, I ruined the surprise. You thought you were safe, but it's very easy to go and find that key. So that was what I was just hoping to illustrate with that really simple noddy example of how to reverse engineer. I definitely, it's a bit dubious from a legal point of view whether it is legal to reverse engineer other people's apps. I'm going to leave that to you guys to decide. Certainly you can reverse engineer your own apps. There's no problem with that. So for those Android developers in the room, go and try it. Run APK tool on one of your apps. See what you get out of it. See what you can find. It's can be quite opening. If you think how easy it is to do, think if like your manager or the person from marketing can do this kind of stuff, or your CEO. That's the kind of level that you can do this. There's tons of kind of blogs on reverse engineer your Android app step-by-step guides. So I'd highly recommend have a try and hopefully use that to justify doing some of these protection tips. So as I said, I didn't want to cover anything that I was going to talk about tomorrow, but I thought I'd cover a couple of things. I have to put this graphic into a slide. It was into a presentation, just like I have to wear this T-shirt. I don't know why, but if you're storing data on the device, you must encrypt it. There's no there's no kind of two ways about it really. If it's anything that's personal to the user or valuable information, you should be encrypting that. And the best way of doing that is to do it without storing a key, and that's the key thing, like, kind of pun intended. But you can use encryption, and you don't have to worry about the algorithms. They're all pretty solid. It's always what you do with the key. Where do you store that? Do you put that in shared preferences? Well, it's kind of pointless because on a rooted device you can get to that. So what you need to do is you need to use something called password-based encryption, and this is just a quick example of it. And again, it's mainly for like reference for anyone sort of coming back to this who aren't familiar. But this basically takes something that the user would put in, like an app passcode or a password, and then it generates an encryption key from that. It's stored in memory, and then the idea is that once they log out or the app goes into the background, you would wipe that, and then when they come back to the app, they would have to put that in again. And that way it keeps the data relatively safe. And you can, you can use things like, now that there's something called the Android key store, which links to the device PIN code, which now lately in Android M also links to the fingerprint reader. You can use that, which also is the same kind of idea, except instead of having to get the user to put in a separate app key, you can derive the key you effectively store it in a place which you can only get at once the device pin code's put in. So I just thought leave that as an example for you guys. This obviously renders quite good, and you can read this text, which is what I was hoping for. It's not encrypted at all. These are commercially viable libraries that you might want to consider if you're doing encryption. Conceal is a really good library from Facebook. They open sourced it maybe a couple of years ago, and they use it to encrypt photos that you download. The photos that they cache them on your SD card, which is fairly the Wild West. You generally don't put anything on the SD card. You certainly shouldn't put anything on there that isn't encrypted. And they use that, and it uses a pretty strong algorithm and a pretty quick algorithm as well to do that encryption. And it's really simple to use. And that's one of the things that all these libraries have kind of got there, very easy to drop in and replace with your the current code you're using. SQL Cipher for Android is a direct replacement for SQLite. It's the same API basically. You just change your import statements, and when you create a database, or when you I don't know why it's doing that. I don't know what's going on. It's like
And take you the second remote. Is that what
Yeah, of course.
that would be too harsh. SQL Server. So it's the same API, but when you create a database, or when you start to read from it, you put in a password, and that password is then used to derive a key. In the same, pretty much the same code examples I showed you over the page. So that could be a good alternative if you're using SQL. If you're using SQLite already, that's a really quick and easy way of getting your app's data encrypted. And if you're using shared preferences, a library that I helped create called Secure Preferences, does the same sort of thing for shared preferences. Or there's an alternate library called Hawk, which is a lot more popular. It's got a better name and it's got a logo. So don't let that persuade you to not using this amazing library. But yeah, it's the same kind of principle. It basically, if you don't give it a password, it will generate one and store it in the same place, obfuscated, but it's kind of better than sort of nothing, and it's kind of like for free. It's very fairly quick. So I just wanted to shout out a couple of libraries. But as you kind of might have guessed from the example earlier, don't use hard-coded encryption keys, because there's no point in doing encryption if you're going to use a hard-coded encryption key, because it's so easy to find this. You can, like I said, the guy from marketing can go and reverse engineer up and find your encryption key. So just don't bother. Just remember that graphic, double facing. And the other thing you might, sort of moving on from encryption, the other thing you might want to put in, and this is the kind of thing you want to put into, release 1 of your app, is this horrible piece of user experience. This is not great user experience. Forcing your users to update the app, blocking them. This is poor. But from a security point of view, it's pretty good. If you've got something in place, so where you can force users to update, if you detect a vulnerability in your app, vulnerability in a particular API that you need to force the app to go in, your app to be updated to use, it's something to consider, and it's something to consider, from day one. And you can get clever with this. You could activate this via like a notification, a push notification that would pop up a system notification to prompt them to update straight away. This probably is going to get less and less of a problem, because automatic updates with the permissions in M, it makes that automatic updates just happen. So yeah. Anyway.
Just like automatic advance, right?
Yeah, just like automatic slides, yeah. So, we'll move to the next slide. I wanted to shout out to, I don't know if anyone recognises this guy, Mark Murphy. If you're an Android developer, you probably know of his book, The Busy Coder's Guide to Android. Really good book. But this library on GitHub has a couple of little utilities which are pretty useful. I just thought to shout out to a few of those. If you're using custom permissions in your app, which is useful if you want to share data between apps that are signed by the same key, that's, I want to say it's probably not something you can do on iOS, but you guys will probably shoot me down. But you could share like access to a content provider on Android very easy. So you could have one app, say, people use the email as an example, one app that downloads, say, attachments, and another app which is your PDF viewer app, and you might want to assign permission and allow them to sort of view all your attachments or something like that. If they were signed by the same key, they could both access the same data, and you could share it that way. There's a Trust Manager builder which is helpful to allow you to use self-signed SSL certificates. It also allows you to do some SSL pinning as well. Signature Utils is a useful app for if you want to share data between apps and you don't have them signed with the same key. So you might be working with partners that you want to say, I can't think of an example off the top of my head, but share not necessarily login information, but you want to maybe pass a token or something, and then it would advance those users on, or some sort of referral. But you want to verify that the app that's passing that information is the app you expect it to be. Signature Util can help you do that. And that's all based on the fact that apps are signed with a key, and that key and that signature stays consistent for the life of the app. So if you were verifying against the Facebook app, you could say for sure that signature should be the same always. There's a bunch of helpers for Android M permissions, and there's also some safe usage of that should say unzipping files. There was a vulnerability found last year which was very bad for unzip, but it has a helper to do that in a nice way. So yeah, worth checking that out if any of that kind of floats your boat, if that's not too much from a British term. I thought I'd just mention verifying the state of the device. You might want to check if your device is running on an emulator, because in production that shouldn't really happen. I was working on a banking payment SDK, and they were really hot on this. They wanted to check for this kind of, if it was running on an emulator, that would be a good indication that there could be potential fraud, or at least this wasn't a genuine sort of customer. So we added a bunch of anti-emulation checks, and Tim Strazier has got a whole bunch of them on his GitHub repo. That's worth looking at. Another one you may or may not be familiar with is the Google Safety Net test. That's part of the Google Play services, and that runs a bunch of vulnerability checks. A side effect of that actually is it checks for root as well, although it's not sort of advertised as a root checking library. I wrote a little wrapper for that to make it a bit easier to use, and there's a sample app on the Play Store as well that you can go in and just run that. But that's just like two ways you could do to run on a device. Two libraries that you can easily drop in to sort of give you an indication of maybe this is not a genuine device. What you do with that data is kind of depends on your app. For the payment SDK thing, we reported all that information in a sort of very vague fraud signals kind of JSON object, and then the server would decide whether it accepted that transaction based on those fraud signals. But yeah. Just moving on to sort of ProGuard. I won't go into sort of too much detail about what ProGuard is, but if you're using it, one of the things that I like to do with it is strip out all my log statements from my app, specifically for my release build. So I know that I'm not going to accidentally one of the top 10 things that kind of developers do, or risks that happen in mobile apps, is that we bleed personal information out to the device log. This is a good way of preventing that from ever happening. So yeah, you have to have the optimized ProGuard config, the optimized option, as well as this. But if you've used ProGuard, you may be familiar with this already. And just while we're talking ProGuard, I thought I'd mention DexGuard, as it kind of answers some of the issues that we had earlier. So we reverse engineered the app I had. It had my secret key, as I call it, my API key that I was fairly not that bothered about. But if I was doing it, for reals, I'd use something like DexGuard. DexGuard is like the pro version of ProGuard. It's got a load of, see what I did there? It is actually the pro version though. It's got a load of useful utilities for doing things like root checking. It does emulator checks, it does debugging checks. But the thing I wanted to draw your attention to is the string encryption that it does. So I can take that, I'll show you over the page, that class that I had, the constants class, I can set that to be encrypted. Of course, the key must be in the APK file somewhere because at runtime it's decrypted and run, otherwise it would never run. But it helps you from a static analysis point of view. It helps you sort of disguise that stuff, and if you combine it with API hiding, which is a way of when DexGuard does its kind of crunching of stuff, it basically turns your calls to say a tamper check, say to a when you're using the API key, it turns those into reflection-based calls. So it might marginally increase the execution time, but what it does is when you decompile the code, it makes it a lot harder to understand. Reflection code is, it's horrible to look at when you write it, let alone when you decompile it. Whereas this is a way of sort of, you just have a line in a config file to say hide access to this API, this method or this class, and it will automatically generate those. So let's have a look at what it looks like. So this is an example, same app, decompiled. Now suddenly you've got, instead of having a nice one-to-one mapping between your class file and your Smiley file, you've got all this kind of weird Unicode crap in there. There's, I think this class, this app was like 20 classes maybe, and so when I reverse engineer it with ProGuard and with and just without that, I would get 20 Smiley files out at the end, maybe slightly more if you're using anonymous inner classes. But with DexGuard, I get something like 300 Smiley files, and they're all a lot smaller. And if you've encrypted any of those, like I did with this one, this is the kind of output you get, which hopefully, if you remember that slide from back at the start, it's a lot harder to read if you can understand that at all. Of course, that's ciphertext, that's encrypted. So that's something I would recommend sort of using. Just to sort of finish off, I thought I'd shout out to a few testing libraries that would kind of help you sort of verify that some of your protections have kind of worked. Another Ferengi reference, the bet was to get 2 in. I've got 2 in. It's called Quak, but I always think of this guy when I see it. I don't know why that is. But so the idea, this is a Python script, and it works with your source code or an APK file, so you can run it on third-party apps if you want to test them. And it does a load of automated tests for weaknesses, it tests for exploits. And what's really cool is it will create an exploit APK file that you install on the phone as well, that you can go and then demonstrate these exploits to people, which I think was pretty cool. It's a good way of illustrating to your project manager, your stakeholder, whatever, you need some time dedicated to fix these flaws. It's been open sourced by LinkedIn, and yeah, worth checking out. And the other one, Droser has been around for a little while, and the book that I co-wrote has got tons of examples of using Droser to sort of fake intents to send apps, to fake access to content providers and emulate permissions and stuff. It's worth looking at if you get into it more seriously. And then on the testing front, there's actually ongoing at the moment. There's a kind of movement to try and bring together a guide, a standardized guide for mobile security testing. This is for Android and iOS. It's trying to kind of standardize them across the board. So it's kind of like saying, okay, these are the top 10 risks for mobile apps. These are all the tests that you need to run and how to do them. It's very tool agnostic, and they're trying to do as much stuff without using specific tools, so as not to favour any particular tool. But that's currently in, they're calling for authors and feedback. So if you've something you're interested in, you want to look at, please go and check out that link. There's a blog article about it, and you could just Google that and you'll probably find it. There's some references for anyone who wants to download the slides, and that's it. Thank you very much for listening.
In the beginning, you said it was really easy to like add malware to apps, like just get an APK and somehow add code to it. So how does DexGuard work then? Like, why is it not possible to remove DexGuard from like an APK?
So DexGuard, that's a code obfuscator. So you can't
It doesn't do the checks runtime. It just does them.
So that there are utilities to run those checks. So I mentioned there's like a tamper check. There's a root check. So yeah, you definitely could. So it doesn't stop you from being able to do that. DexGuard and ProGuard are code obfuscators. They just make the code harder to understand. So you could still technically go and remove those, but it just makes it.
It's just very hard.
Yeah.
Okay.
So the kind of professional Android security kind of people kind of laugh at ProGuard and don't see that as a protection really, because people can read bytecode, let alone obfuscated code. But DexGuard is just that level above that, and it's really kind of, I guess it's kind of like increasing the time and the skill level it needs to hack or to attack. And for most apps, that's enough for people to move on to the next app, to the competitor's app. It's probably not enough for banking apps and stuff like that, but that's where the app is just part of your security kind of your attack surface. You've got to make sure your APIs and that are all secure as well. But
what I noticed from iOS was that all these automated tools will cover what probably 80% of the people will do, which is basically nothing. And so like these automated tools will just look for all these common stuff, and then as soon as you do something, then that will already stumble the tool, and people are just probably not too motivated to like sit down and actually look at your code.
When you say tool, you mean like a tool that's testing for security vulnerabilities, or tools that are looking to sort of attack it?
Well, we used to have tools that will just, you feed them the IPA file, which is the IPK kind of thing, and then they'll just extract your API keys and remove your whatever ifs that are just checking for purchases, things like that.
Yeah.
But as soon as there's something that will stumble the tool, then people are actually not having infinite time to sit down and
totally.
do the code, right?
And that's really, I guess, the ethos really of any kind of security enhancements that you can put into your apps is just really to beat the automated tools and to make it so it's not worth the time investment. So obviously, if you're storing nuclear launch codes, is my favorite example, then you probably shouldn't have an app for storing those. I mean, I tried to tell them, but no. But
I can launch them from here. Woo!
well, yeah. Why not? iPhone or Android, it's multi-platform. But for that scenario, then obviously people are going to spend a lot of time and a lot of effort to try and get those. Nuclear launch code is probably a crap example, but if it's if you're encrypting, like say if you're encrypting your data using a password-based encryption that the user's putting in, then that data is fairly safe on that device. I mean, the way you would get at it is on a rooted device. You would read the encryption key out of the memory, so you're not completely safe. But then that's you're cutting down the chances of that happening, and it has to be a very targeted attack. So yeah, I'd say that in general with all, certainly all my security recommendations, it's all about raising the bar, the amount of effort and the time required. Yeah. Cool. Yeah, question about that?
You have said a lot about reverse engineering, and the most obvious way to prevent rebuilding of the app is to checking a signature of the app. Mm-hmm. Is there any other way or better way to make it harder to rebuild?
There are a couple. DexGuard has a tamper detection as well, built in. And actually, I didn't mention signature check explicitly because I'm going to mention that tomorrow. But yeah, good question. Yeah, I'm not. The thing is, anything you put into the app can be removed. That's part of the issue. So yeah, you could do something like in an OAuth kind of base thing where you get the app to sort of sign in and pass it the signature, and it gives you back a token that then it can use for subsequent API requests. But again, even that, in a particular device scenario can be intercepted. So I think the signature check is a nice one because it's very easy to do, and I think it's just a case of hiding that check and making that more difficult to remove. There is obviously things like the Google Play do the license checker library. I can't remember what it's called now. They changed the name of it, and I remember the old one was really easy to hack and remove, especially if you just copy and pasted the example from Google, which a lot of people did, and so people wrote automated tools just to remove those. But people they do say but then they don't stop you from copy and pasting. So that makes the world go around, right? Copy and paste. But yeah, no, I can't think of a better one off the top of my head now. Cool. Well, brilliant. Well, again, thanks for listening and thanks for staying around for an Android talk.